Today our topic is how perceptron works. I will explain with the help of one scenario in where we have a training data set of height, weight and labels are human or giant. So we have some values h1 height 1 and w1 weight 1. Based on the height 1 and w1 we will consider him as human. If he is human we will consider him as label 1, otherwise label 0 for giant. So in this situation I will take some samples hi, wi and consider here as 0, here h2, w2 and consider him as a human. So how perceptron works we will understand first. These HW are the input parameters h1, w1, h2, w2 and A, B are the weights and Z is the output and Z equal to A times of H plus B times of W equal to Z. Z greater than or equal to 0 considered as human, Z less than 0 considered as giant. Here we have to compute the A and B values such that the Z value will be greater than or equal to 0 when we will take the training sample of human and Z value less than 0 when we will take the training sample of giant. So how it actually? Let's continue from here. Here we know we have to compute the A value and B value such that the A into H plus B into W for corresponding H comma W in the human category and giant category, the Z value would be 1 for the human category and the Z value will be value will be greater than or equal to 0 for human category and Z value will be less than 0 for giant category. So our aim is to compute the A and B values which will satisfy the whole training samples. For that, this perceptron model has some algorithm. In that algorithm, what they're actually is doing is like they will take the first sample, which is first sample h1 and w1. With the help of that sample, they will compute the Z value. Z is equal to A into h1 plus B into w1. So Z equal to A into h1 plus B into w1. So from here the Z value could be greater than or equal to 0 or less than 0. But the A and values here not yet initialized. Here they initialize the A and B values with some random values. From there they will compute the Z. So this Z won't be greater than or equal to 0. No need to be greater than or equal to 0 because this A and B are not yet optimized values which satisfy the whole samples. So initially they will initialize the A and B value with some random values and then they will try to compute the final value with some algorithm. The algorithm how it works is like when the first sample they have substituted in the equation, if the Z which came from the first sample is not expected, means this first sample belongs to human sample. So not expected means this Z value is coming as less than 0. If it is coming less than 0, then what they are doing is like they are changing the A and B values to some new values. That is A to A becomes A plus H1 and B becomes B plus W1. These are the new two values. If the z value is expected, like if when we're substituting h1 and w in the equation and z value is greater than or equal to 0, then they are not updating the a and b values. So this is the thing when z greater than z not greater than or equal to 0, that means less than 0. Okay, if z is greater than or equal to 0, they are not changing the a and b values. So these are the new a, new b values. From here, they're again giving the second sample to the equation. Now the a and b values are not the randomly initialized values, these new a and b values. From here, they again calculate the z value. If it is expected, that means the second sample is here human sample. So if it is expected greater than or equal to 0, then they won't change this new a and new b. If it is not expected, then they again add this whole thing with the a plus h1 plus h2. That means a plus h1 plus h2, b plus w1 plus w2. This is what they are doing. If from here also the new computed z value, let's say this is z1 with sample 1, z2 which is computed from the sample 2, if with the new a values like a plus h1 and b plus w1, if still it is less than 0, then they are doing the same thing. In the middle, they got the sample of giant where the label is 0. So they will compute this new they will use this new value like a plus h1 plus h2, b plus w1, a plus h1 plus h2, and b plus w1 plus w2. These are the new values. With these values, they will compute the new sample. Let's say now the sample is like let's say we came to this sample where the label is 0, which is giant. So in this situation, they will again compute the a plus here let's say the updated a value, let's say something like this. They will compute this hi, which is from the last sample, plus p plus w1 plus w2 something in the middle samples, and wi, and they computed this value. If it is expected, what would be the expected value for the giant? It has to be less than 0. If it is less than 0, they won't update this new a and new b. If it is greater than or equal to 0, then let's say this is new a, right? For this, they will subtract this minus hi. So this whole, let's consider as capital A. So new value will become a minus hi. And from here also it become b minus wi when not expected situation. In this case, what is the not expected situation? Z greater than or equal to 0 is the not expected situation at the ith sample. So at finally a minus hi and this is b, capital B, b minus wi. So a minus hi and b minus wi. These are the final weights. So with these weights, we can compute the any unseen data and substitute in the a into h plus b into w equation and compute the z value. If the z value is greater than or equal to 0, it will be human. If it is not, then he is giant. So this is what they are guaranteeing. Okay. But is this algorithm is guaranteeing for the completion of first epoch? Here again, the epoch means they will in this algorithm they won't stop here itself. They will again go from the h1 first sample and again do the same process again and again until the last step. This is considered as one whole epoch. In that way, they will do 100 epochs. N is equal to 100 epochs. So at 100th epoch, like that they are doing at 100th epoch, let's say the whole a and b are not changing at all. That means this is the these are the optimized value for the at least giving seen data where expected z is coming. So they won't update anymore and they won't go for one more epoch. So this algorithm is guaranteeing that you will find the a and b values after some epochs. Okay, but is it guaranteeing that it will definitely stop at some point without updating a and b? Like I said in previously, at the 100th epoch, a and b values are not updating at any sample. That means there is no more epoch is needed. So will it works for every data set? So for that they are saying that, let's say for a 2D data set, here height and weight. So for every h1 comma w1 we can for human samples we will consider it as a cross, and giant samples are considered as dots. So if we separate in the 2D plane with the plane line, linear plane line, then if the data set looks like this, then definitely this algorithm will converge at some epoch. That's the guarantee they are giving. So now we will try to understand how, when z is not expected, they are adding something. When z is not expected, they are subtracting something. How it works, like what actually internally is happening. So for that, before going that, we will give one more example. Let's say human samples are like this. So here we can't separate linearly these four. If we want to separate all these things, we definitely want curvilinear line, which is upper part of curvilinear line is giants and lower part is humans. In this way we can separate, but it's not a linear line. So for this data set, where let's say 1 1 and this is 1 minus 1 minus 1 minus 1 minus 1 1, if you take this height and weight values, with that height and weight values, if you try to compute if you try to compute unseen data, we can't able to train using the single perceptron. That's what they are saying. Okay, so now we will look at the two things. When it is not expected, they are adding. When it is not expected situation, in the giant case, they are subtracting. So how it actually internally works? Let's look as a normal mathematician. Consider a situation. Let me wait. So yeah, consider a situation where so these are the some 4 points, like this cross one are the human samples and the dot one are the giant samples, height, weight. So from this, what the algorithm is actually doing, initially z is equal to a into h plus b into w. They are initially a and b are the random values. So with that random values, we can see this is a plane equation, 2D plane equation. So with that random value passing through 0, some a and b. So ah plus bw is equal to 0. This is our, let's say, plane equation. Okay. Whatever the points on the right side, if you substitute in the equation, definitely it will get greater than or equal to 0. Whatever the points on the left side, rather than saying like that, in the planes we know that a and b, ah plus bw is equal to 0, and if you plot the a comma b as a one vector, and if you plot here, let's say a comma b is some point here and the vector is a comma b. If you plot here, this line definitely perpendicular to the plane. That's what we can confirm from the plane and planes. If you want, you can check with some examples. this a comma b, if you draw a vector, that vector definitely perpendicular to this plane. Okay, so now, so whatever the points on the vector side, those points if you substitute in this line, then definitely it will always be greater than or equal to 0. If you want, you can try with some examples. And whatever the points on the below the, like opposite to the perpendicular vector, though that value will give less than or equal to 0, and whatever on the line it will give is equal to 0. So this is the thing. So what they are doing, when AH plus BW is less than 0, I mean in our case there is a point, so in our case there is a point here. Let's say this is the first this cross is the first human sample. Whenever we try in the a into h1 plus b into w1, definitely it will give less than 0 because it is in the left side of the plane. Okay, but what our expectation, greater than or equal to 0. So in this situation, if the expectation not matched, the a and b values we have to update with the what values, a plus h1 and b plus w1. So what they are doing is like, so let's say this is h1 comma w1 vector, h1 comma w1 vector. So whenever we h1 comma w1 vector, if you saw that vector, before going to that topic, one small example. If you have vector a, if you have vector b, if some vector a added to vector b, the resultant vector a plus b definitely comes towards the b. If you want to subtract a minus b, the resultant vector a minus b will move away from the b. That's the thing. That's the thing. If you want to check again with this some basic triangle laws. If this is a and this is b, if you want a plus b, so a is in this direction, this is a, right? So a plus b, so this is the a plus b vector with some triangle laws in this direction, which is nothing but a b. So a plus b comes under as a plus b. So yeah, in this way, so which is parallel to, if you draw, this is the vector. So this is a plus b. See, a is here, a plus b comes towards the, sorry, b is here, a is here, a plus b to go towards the b. So whenever we add some vectors, that resultant vector is move towards the vector which you want to add. And if you check with the subtraction also, it will works fine. So in the meanwhile, no need to go for the deep maths. Just comes to here. When we add h1 comma w1 and a comma b, actually h1 comma w1 on the left side of the plane, which is not expected. So we are adding these two vectors. If you add this vector, this vector will move towards the h1 comma w1. If it is moved towards like that, the plane equation, which is actually has to be the plane equation, the plane is perpendicular to the line, right? If perpendicular is move at anti-clockwise at some angle, then plane also move at anti-clockwise some angle. Then what happened? This cross is moving towards the positive side of the plane. See, initially it is in unexpected. It is not in the expected position. Now it is went to the expected position by adding h1 plus w1. So So this plane will this plane will, after updating a and b with the new equation, this plane will move like this, and the normal is like this. This is the plane line. Now these two crosses are on the positive side. Now again they will go for the next sample, this negative sample. So yeah, for the negative sample, this is lefter side, lefter portion. I said for the lefter portion, if we compute the plane equation, it definitely come as less than 0. So we won't update the a and b. Now go for the next sample, this fourth sample. Whenever you go for the fourth sample, if you see that it is not in the expected position, the expected value has to be less than 0, but here it definitely comes at a greater than 0, I said. So if it comes at a greater than 0, what we will do? Minus h1 minus, so let's say this is hi bi. If we a minus b, if we do, this vector move away from this hi comma bi. If it is move away from that, this plane also move, because this plane always want to be in perpendicular. Actual normal has to be in perpendicular to the plane. So the new plane will rotate from here to here, and this new normal will move from here to here, away from the hi comma bi. So the new plane will be from here to here. So isa, and this is this one. So these two crosses are on the positive side, these two negatives are on this side. Now they again will compute, the one epoch is completed for 4 samples. Second epoch again start with this point, no update, no update, no need of update, no need of update. They stopped. So at first epoch only we get the best a comma b values. Okay. So this is the how single perceptron works, and what the algorithm they are using for this thing, what the mathematical intuition behind using this algorithm, and yeah, for conclusion, the single perceptron will only work for the samples where we can separate the samples with this linear line. If we can't separate, then it won't work whatever times you want to do, because with mathematical thing also, if you want, we can explain. Yeah.